Have you ever heard someone say that two particles can stay connected even if they are billions of kilometers apart? It sounds like something straight out of a science fiction movie. But here's the crazy part, it's actually real. Today, I want to talk about one of the strangest concepts of physics, quantum entanglement. Let's start simple. Imagine if you have two magical coins, you separate them, you keep one on Earth, and somehow send the other to Mars. Now, when you flip the coin on Earth and it lands on heads, the coin on Mars instantly becomes tail. Sounds impossible, right? Now, before you jump into the comments, this isn't exactly how quantum entanglement works. It's just an analogy to help you understand the idea. In reality, quantum entanglement happens when two particles become linked in such a way that their quantum states are connected. Sounds interesting, right? Now, once these particles are entangled, measuring one particle with the second particle becomes extremely easy. One particle tells you something about the other, even if they are separated by enormous distance. Now, this is what shocked the physicists. Because according to Einstein's theory of relativity, nothing can travel faster than the speed of light. So how can two particles seem to know what exactly is happening to the other instantly? Einstein himself didn't like this idea. He famously called it spooky action at a distance. For years, many scientists believed there had to be some hidden explanation. Maybe the particles secretly carried information all along. Maybe quantum mechanics was incomplete. Then came decades of experiments. Scientists tested entangled particles over and over again. The results consistently supported quantum mechanics. The particles really do exhibit connections that can't be explained by simple hidden instructions. Here's the important point. Even though the connection appears instantaneous, you cannot use quantum entanglement to send messages faster than the speed of light. That's never possible. This is one of the biggest misconceptions. When you are measuring one particle, you don't control the outcome. We simply discover it. Because of the randomness, entanglement can't be used as faster than light communication system. So Einstein's speed of limit still holds. Then why is entanglement such a big deal? Because it opens the doors to incredible technologies. Quantum computers are the quantum effects, including the entanglement, to solve certain problems much more efficiently than the classical computers. Quantum cryptography can create communication methods that are extremely scarce. What's fascinating is that quantum entanglement isn't just a theory anymore. It's been demonstrated countless number of times in laboratories around the world. Researchers have even created entangled particles over hundreds and in some experiments more than 1,000 kilometers using satellites and optical links. Think about that for a moment. Two tiny particles separated by enormous distance, yet still described by a shared quantum state. The universe is far stranger than our everyday intuition suggests, and maybe that's what makes science so interesting. The deeper we look into reality, the more we realize that nature doesn't always behave the way we expect. Quantum entanglement reminds us that the universe still holds mysteries we are only beginning to understand. If you found this interesting, let me know what mind-bending science topic you'd like me to talk about next. Thanks for watching and see you in the next one.